Hello, I'm Saladin HI. Today we are going to look at equilibrium. At the end of the lesson, we'll be able to define equilibrium, state the conditions of equilibrium, define moment, and state the types of stability we have. Equilibrium of forces. The body is said to be in equilibrium in a given direction if it makes no resultant movement in that direction. The term equilibrium means that an object keeps doing what it's doing without any change. Therefore, if the object is moving, it will continue to move in a straight line. If it is stationary, it will remain stationary. The object will also not start or stop turning. There are conditions required to things. The forces on the object must be balanced. That is, there must be no certain force. The sum of clockwise moment on the object must be equal to the sum of anti-clockwise moment. That is, the principle of moments. When the force accumulates on an object is balanced, the object will remain in equilibrium. If the two conditions are met, then the object will be in equilibrium. Conditions for equilibrium. When the body is in equilibrium. Conditions for equilibrium. When the body is in equilibrium under the action of forces, the following conditions hold. 1. The sum of forces in one direction is equal to the sum of forces in the opposite direction. 2. When the body is in equilibrium under the action of turning forces, the total sum of clockwise moments about a given point equals to the total sum of anti-clockwise moments about the same point. This statement is known as the principle of moments. 3. When a body is in equilibrium in a given direction, the resultant force acting on the body in that direction is the resultant and defined forces. The resultant force can be defined as a single force that can be used to represent or replace a system of forces. Or resultant is a single force that can replace. Or resultant is a single force that can replace the effect of a number of forces. An equilibrant can be defined as a single force that is needed to keep a body in a state of equilibrium, or is a force that is exactly opposite to a resultant. Equilibrant and resultant have equal magnitudes but opposite directions. That is, the angle between them is 180 degrees. Parallel forces. They are forces attached with an inextensible string on a horizontal platform or surface. Moment of a force. The turning effect of a body is known as moment. The moment of a force about a point is defined as the product of the force and the perpendicular distance from the point to the line of action of the force. The formula is moment equals to force times perpendicular distance from the pivot. Moment have units called Newton meters or Newton centimeter, depending on whether the distance is measured in meters or centimeters. Center of gravity. The center of gravity of an object, sometimes called the center of mass, is the point through which the weight of the object acts. For a symmetrical object of uniform density, such a symmetrical cardboard shape, the center of gravity is located at the point of symmetry. The center of mass or center of gravity of a regular shape can be found by symmetry. When an object is suspended from a point, the object will always settle so that its center of gravity comes to rest below the pivoting point. This can be used to find the center of gravity of an irregular object or shape. The center of mass of a regular shape can be found by symmetry. When an object is suspended from a point, the object will always settle so its center of gravity comes to rest below the pivoting point. This can be used to find the center of gravity of an irregular shape. The center moment states that for a system to be balanced, the clockwise movement. So in the diagram above, force F2 is supplying a clockwise moment, while forces F1 and F3 are supplying anti-clockwise moment. So we can have the equation to be F2 times D2 equals to F1 times D1 plus F3 times D3, torque or couple. This is a pair of equal forces acting on a body in different directions. The turning point of a couple is called torque. Torque equals to force times perpendicular distance, force between them, that is F times D. From the video clip, you can see that torque, as it is defined as the turning force, it tends to cause rotation, and here torque of couple equals to OP times F or OP times F, where OP and OQ are the radian. Stability. Types of stability. 1. Stable equilibrium. A body is said to be in a point of stable equilibrium if, when slightly displaced or tilted, it returns to its original position, e.g. a cone resting on its base. 2. Unstable equilibrium. A body is said to be in an unstable equilibrium if, when tilted or slightly displaced, moves further away from its original position, e.g. a cone resting on its apex end. 3. Neutral equilibrium. The body is said to be at a point of neutral equilibrium if, well tilted, it rests in another position which is different from its original position, e.g. a cone resting on its right side. Equilibrium. This is the kind of equilibrium possessed by stationary bodies. All bodies at rest are in a state of equilibrium. 5. Dynamic equilibrium. This is the type of equilibrium possessed by bodies moving constant speed or uniform velocity. Thanks for watching.